Hi guys, Frankenstein here. So today I want us to take a look at the clipper circuits. So for the first one, we look at the positive clipper, and then second one, we'll look at the negative clipper. Now we're gonna analyze these waves under AC conditions. So you're gonna be inserting a sine wave, which is an AC wave in a way. So the first one, which is a positive clipper, the circuit which will be given will be looking like this. The diode will be in the reverse. Then a resistor, and that. So V out will be taken from here and V in will be inputted there. Now, understand that this diode is an ideal diode, so it just needs it to be in the forward bias and it will automatically be replaced by a short circuit, right? So what we'll do is insert a sine wave, which this is the input wave form which will be inserted, so an AC wave, right? So this is in the wave input, which is an input, and then now we must find the output wave. How does it look like? So let's try and draw another wave. Usually draw this way and then you do a dot there. This is the positive cycle, this is a negative cycle, right? Now we want to know what will be happening in the positive cycle. So in the positive cycle, the positive will be here, negative will be here. So current should be moving like this, that, right? But current won't be able to move because this diode is in the reverse bias, right? So since it's in the reverse bias, so meaning that no current will flow in the forward or in the positive cycle. So the voltage there, it will be on the zero section. So no wave will be generated on the output section. So that meaning that what's happening on that diode there, it will be replaced with an open circuit. So no current will flow in the circuit. So meaning that for the positive cycle, no current will flow. But now let's bring back the diode there. And now let's analyze this according to the negative cycle, meaning that if you go into a negative cycle, you must change the polarities. So meaning that now we have negative here and we've got positive there, right? So current should flow like this. Will current flow according to the diode? Yes, current will flow according to the diode. And current, which if current flows, meaning that you will replace that diode with a what? A short circuit. So replace with a short circuit. And if I'm inserting a wave there, it will be read by that resistor there and it will be generated on the output side. So the wave there will be as it is. If here this was V max, even there that is V max, but negative, by the way, because in the negative cycle, right? So that's how you'd really analyze that. And then if you don't want to have the circuit looking like this, you can write the circuit in a way. When you're analyzing, don't write it exactly on the answer sheet, but when you're analyzing it, you might analyze for the positive cycle, put your circuit like this with the battery there, a resistor. And that is for the positive cycle. And then for the negative cycle, when you analyze it, you must just change the polarities, so it will be something like this. That is for the negative cycle. So you might analyze according to that. So you know that this will be the positive, positive, or negative, right? So current will flow this direction for this bottom wave. Current will flow like this. That's current. Then current will flow like this. It's current there. So that's another way to do it if you feel like this one is a bit confusing. But now let's jump into the negative wave. How can we analyze the negative wave form, right? The negative clipper. So negative clipper is no more different. So it's going to be the same thing, but the difference is that the diode there is in the forward bias, and at those nodes there where they're going to be taking their output VO, and then here inserting the waveform Vin, right? Now remember that we are inserting an AC wave, so a sine wave, something like that. And remember that for us to analyze that, we need to draw those dots there to make sure that we account for both wave, the positive and the negative wave, right? So for the first one, we're going to check how is current flowing. So we can see that current is flowing for the positive wave, for the positive for this cycle, positive will be there, negative will be there, and then meaning a current will flow this way. Or if we want, right, let's do this method I showed you, by the way, so you can see it's the same thing. So what you're gonna do is put a battery there, and you know this is the positive, this is the negative, right? Will the voltage push the current for this direction? Yes, it will. So meaning that the input wave will appear on the output section, so meaning that it will appear. So you can just draw the way it was. So if this was V max and this was negative V max, so even on the output section, V max will be red, right? So current will flow, the current will flow for the positive cycle. But since we've analyzed the positive cycle, let's check the negative cycle and see what was going to happen, right? So negative cycle, we just change the polarities. So we can see that this is the positive, this is the negative, right? So meaning that current will be flowing in this direction. Will current pass through this diode? No, current will not pass in this diode. So meaning that we can treat that diode as an open circuit. So we play that diode with an open circuit. So meaning no current will flow in that circuit. So you can just put that voltage there at 0. So on the output side, on the negative cycle, no Vmax or no negative Vmax will appear. So the final wave which we expect is this wave, which will be generated from the original wave. So I think that's about it. So the trick to take here is that you must analyze for the positive cycle and analyze for the negative cycle, and then you'll see as you change positive cycle, meaning that you are having your positive being on the top, your negative in the below, and then for the negative cycle, meaning that you change the polarities, therefore the negative will be on the top and the positive will be on the bottom. So that's one of the things you might do. I think we'll meet on the next one. Cheers, guys.